This video tutorial covers counting points and polygons. And once we count up the points within the polygons, we'll apply a rate of instances per polygon. So to do that workflow, what we need to do is first understand our two files. So thematically, the first file here are points on top of polygons. So obviously this is in New York City and the 5 boroughs. And these are 311 calls. In this case, it's for COVID social distancing complaints. There's 60,000 plus recordings at this point in time. So this is several months, good, almost half a year into the COVID crisis in New York City. And these are complaints that are called into 311 system regarding social distancing. So typically these are going to be complaints, people complaining about other people not complying by state mandates. So this gives us sort of an interesting spatial pattern of what's happening in the city in terms of social distancing concerns. So what we really want to do is just understand roughly per borough, what's the rate? And we can see looking at the map that Staten Island is obviously a lot less populated with these complaints. Outer boroughs, Bronx, and also Brooklyn, towards the eastern edges, are not nearly as evenly and densely distributed as they are at Manhattan and Brooklyn along the western coast. So what's happening here, this is really a function of urban density. If we just look at it, sort of the points on top of their geographies, their polygon geographies. But to do this, quantitatively, we want to use a GIS tool, and that's going to be counting these points within the polygons themselves. So let's go ahead and do that part, and then we also need to calculate a rate based on square area. We could also do a rate in terms of population, but we just don't have any population data in this particular demonstration. First thing to mention before we get too far along is if we open up the attribute, we can see within this particular attribute, there's a shape area and a shape length, and the shape area is a long number, as is the shape length. So for each one of these polygons, Manhattan, Bronx, Staten Island, Brooklyn, and Queens, the shape area is representing square feet. And we know that because the original file comes from city planning, New York City planning, and that particular projection that they utilize for their data is the New York State Plane FIPS 3104, which covers Long Island and New York City, and that is in a US foot. So if we're talking about area, we're talking about square feet. And so we just need to apply a calculation to get the correct square area to get our rate. If we want to be a meaningful unit. So in this case, we'll want it to be square miles. So we want to know how many complaints are happening per borough, but also per square mile within the borough. So the count is going to get us per borough, and then the square area calculation is going to get us per square mile. So let's go ahead and start that workflow. So the first thing we want to do is do the first part of two parts, which is counting the points within the polygons. And so that's relatively easy. We're going to get a vector, and then we utilize analysis tools and count points on polygon. So we want to make sure that we get this correctly. So we're guided with the prompts. So our polygons are going to be this GeoExport WGS84, and our points are going to be our 311 points. We're not going to weight it. We're not going to worry about any particular fields. We're going to accept the default, which is called num points. We could name this something else if we wanted to. But essentially, we're just counting and producing a field that's going to give us a recording of those counts per polygon feature. So go ahead and run that. It's going to run the algorithm, and in this case, it completed it within 3 seconds. I did this a couple times before, and it never went above 5 seconds, so it should go pretty quick. So go ahead and close this. Now, if I open up the temporary layer, remember, if we have a temporary layer, it's going to give us a little icon. It says temporary scratch layer only. The contents will be discarded after closing the project. So we're probably going to want to export this out to save it into a directory. Let's go ahead and look at what the attribute table gives us. So now we have the same information for our shape area per borough, which is great because it's transferring that attribute table from the original GeoExport WGS84. We have borough name, which is important, and we also have the counts now. So we can see that of all the boroughs, Brooklyn has the most counts, but Manhattan sure isn't far behind. And Manhattan's significantly smaller than Brooklyn. And if we look at the map, we can see what's going on here is that Brooklyn just covers a larger square area. So the rate in Brooklyn might actually be smaller. We'll go ahead and check that here in just a second. So let's do this now. Let's go ahead. I'm going to make sure that I'm not selected. See, I have a selection. That's the bright yellow here. I'm going to click off selections. So I do that with this little box up at the top, deselect features from all layers. So nothing's selected right now. I'm going to go ahead and do this calculation now. So, but before I do that, I want to export out count and save that. Okay, so I'm just going to export this out to my folder that I'm working in. And let's just call this count. I'll just call it area calculation. And we'll go ahead and save this, say OK. And the next thing we need to do is let's remove some things so we don't get confused. So I'm going to remove this layer. And I'm going to remove the original two because I don't really need that at this point. Okay, I'll keep the points along for the ride here. So what we're going to do is go ahead and open up the attribute table. And we're going to be creating a new column now. So we want to know square area. And then once we have square area, we'll calculate a rate per square mile based on the number of points divided by the square mile. Okay, so to do that, let's go ahead and create a new column. Okay, so what I do here is I go up to my Open Field Calculator. You can get to it in two places, up on the top toolbar, or you can get to it within the attribute table along the top flank here of toolbars. Open Field Calculator. I'm going to create a new field. I'm going to give it the output name of square mile. It's going to be a decimal number. I can accept the defaults here, 10 with 3 precision. And now I'm going to go get my current shape area. Okay. And then I'm going to apply a factor to this because currently the shape area is in square feet and I want to make it square miles. So that conversion is a long number, which I'm going to go over to a little cheat sheet here and copy out. And I'm going to pop it in. Okay, so shape area times this factor is going to give me square miles. And I say OK. And sure enough, it produces it. Yeah, we can check to see online. Let's do that real quickly. Let's see the square area of Manhattan. Let's go see what that is just to make sure we're right. Let's get into a browser here. Oh, here it is. Okay, I'm just checking this off my screen. So this is going to be Manhattan. Square area. What does it tell me? This is from Quora.com, so we need to be careful about our source. The land area it's saying is 22.82 square miles. Let's see what we got. We got 2283, so that's about right. Next thing we want to do is go ahead and make sure that we have a rate that makes sense. So it's basically these num points, the 311 calls per square mile. Let's go ahead and I'll just call it a rate. Okay. And this is going to be a decimal number. It's going to have output length of 10, precision of 3. One quick note here, as I'm doing this, you can see that I have a little icon in my layers that shows a little pencil. That means that we're in this editing mode where we're creating fields. So if you're having some problem with the field calculator, you might want to make sure that in your layers panel, you're actually toggled on to be editing here. So now we're going to go ahead and create this rate. So it's going to be, we're going to go into our fields. We have num points in square miles. So we're going to go to fields and values. So it's going to be num points divided by square mile. Okay. And we will then go ahead and say, okay, there it goes. Let's see what we got. So Brooklyn's got 273 and Manhattan's got 718 in terms of a rate. So even though the count of Manhattan's slightly lower, the per mile density of these complaints is much higher than it is of Brooklyn. And that makes sense because Brooklyn's just larger, it has more space, it's able to collect more complaints, but the density of those complaints is spread out across the full borough. Okay, we could also do this per population too, where we could say, here's the number of complaints per a certain population within one of these geographies. We just don't have the population data right now for this particular demonstration. All right, so that's how we do this. And you can see currently I had selected within my attribute table. So if I go back to my attribute table, we can see that Manhattan's selected, and here it is selected on the screen. We don't want that, so we're going to use our little deselect all, and he goes away. But here's the issue. I'm still in an editing session. So we can see that I have that pencil on, and to right click, and I'm going to say toggle editing. It says, do you want to save these changes? And I say, yes, I want to save it. And then it goes to a unediting state, and then I can go ahead and export all this out just to be on the safe side. So I've put it into a shapefile. And I might call this final count calculations. And go ahead and say save. Say okay. And there's my data. So I can go ahead and symbolize this. I can make get a plotly charts out of it. Whatever way you want to go ahead and proceed to visualize the results of all the complaint points per borough.